Artificial intelligence seems almost magical in what it can do today, generating images from text, beating world champions at complex games, and even writing essays. But behind this apparent magic is something much more logical. Today, we're going to demystify how AI really works, without diving into complex mathematics. At its most basic level, artificial intelligence is pattern recognition on a massive scale. Think of it like this. Humans learn by observing patterns in the world and making connections. AI does essentially the same thing, but it can process vastly more data than a human ever could. The foundation of modern AI is something called a neural network. Despite the intimidating name, the concept is straightforward. Imagine a series of interconnected filters that data passes through. Each filter looks for specific patterns and passes information to the next layer of filters. The first layers might detect simple patterns like edges or colors in an image, while deeper layers combine these simple patterns to recognize more complex features like faces or objects. How does AI learn these patterns? Through a process called training. During training, an AI system is shown thousands or millions of examples. For instance, to recognize cats, the system is fed countless cat pictures. Initially, it makes random guesses. When it guesses wrong, the system adjusts its internal connections slightly. Over time, these small adjustments add up, and the AI becomes increasingly accurate. This process mimics how humans learn through trial and error, but at an accelerated pace. The key difference is that humans can learn from just a few examples, while AI typically needs enormous amounts of data. Decision-making in AI works through probability. When an AI system encounters new information, it calculates the probability that this information matches patterns it has seen before. If an image has enough cat-like features, the AI might determine there is a 95% probability it contains a cat. Most AI systems today are what we call narrow AI. They excel at specific tasks but lack general intelligence. Your smart speaker can answer questions but doesn't understand what it's saying. It simply recognizes patterns in your speech and matches them to appropriate responses from its training. In contrast, general AI would possess human-like understanding across domains, something that remains theoretical despite recent advances. The AI generating art or writing essays isn't thinking in a human sense. It's predicting what should come next based on patterns in its training data. Real-world applications demonstrate this pattern-matching nature. When AI diagnoses diseases from medical images, it's identifying visual patterns that correlate with certain conditions. When it recommends products, it's finding patterns in user behavior that suggest preferences. Even AI that plays chess or Go is recognizing patterns in game states and predicting optimal moves. The power of modern AI comes from three key elements: massive amounts of data, significant computing power, and increasingly sophisticated algorithms for pattern detection. Together, these allow AI to find subtle patterns that humans might miss entirely. Understanding AI as advanced pattern recognition helps demystify its capabilities and limitations. It excels at tasks where patterns can be learned from data, but struggles with abstract reasoning and common sense. AI isn't magic. It's logic at scale, finding connections in data and using those connections to make predictions about new information it encounters.